Hello and welcome to another video from Ellensburg Amplifier Repair and Service. My name is Todd, and what we have here today is a Memphis, here, let me read the tag here real quick so I get the right name here. So it's the Memphis 16-MCD1000. And I just wanted to do a quick video of what not to do. So this amplifier came in and it obviously had a blown power supply section. So it's got 1, 2, 3, 4 burnt gate resistors, completely burnt, and the other 4 aren't burnt on the power supply. The failure of the power supply took out the power supply driver card here, which has the A1266s coming off pins 9 and 10 of the TL494. So that failed, which I have 2 new transistors ready to go into the card. And so I'm just going to start at the front here at the power supply and work my way back. So under initial inspection of this board, I found that there was 4 IRFB 640s in the 4 slots here that don't have the burnt gate resistors, and I have 4 IRF 3205s in the spot here where it is cooked. So there's one problem right off the bat. I would call this a severe mix of transistors. Again, when that failed, it also came back and damaged the driver card. So you can see how this stuff kind of cascades. And then you'll ask yourself, well, why did the power supply fail? Well, then you just got to keep working your way through the amplifier. So there are shorted output transistors. Let me turn my meter on here just so I can double check and give you guys the proper information on what's shorted and what's not shorted. So this bank is good. Let me check this bank. 4.5 ohms, 24 ohms, 20 ohms. So 20 ohms, 0.83. So this transistor right here is a dead short. And 20. So I was checking the output transistors and I was looking around going, okay, so we have the IRF 9640s. So you have 4 of them here, 9640s, and then I have 2 31N20Ds here. And it looks like it's factory soldering, but I have reference pictures that show 640s in this bank. So this I'm going to look into. But I come over here and I have the IRF 9640s here, and then I have a 31N20D here, and I have a IRF 640 here. So they put a 31N20 here, and they put a 640 here. Again, what's the rule of thumb on transistors? Don't mix your transistors. These 2 transistors are not anywhere close to being really the same when it comes down to the fine print of these specifications of these. So I can see why this amplifier had a failure. Someone had repaired this in the past and just put completely the wrong transistors in. which of course won't work. So I'll have to remove, what I'm going to do is I'm going to remove this whole bank here. I'm going to go ahead and leave this bank in. These amplifiers will run with one card. So I'm going to leave this side alone just to see and make sure that I have a platform that works and I can test both drive cards in this one location, as long as these 9640s and that 31N20D is functioning the way it should. These 31N20Ds can get pretty finicky. If you're familiar with the Orion 2500s, the earlier big chrome ones with their drive cards and their output transistors, the 31N20Ds are pretty particular. So that's what I'm going to do is I'm going to replace the gate resistors here. And my reference pictures do show the 3205s in. So I'm going to put the 3205s in. These have, what is that? That's 100 ohm. Nope, I'm wrong. That's a 22 ohm gate resistor, red, black. So 22 ohm gate resistor. So I'm going to put the 3205s in, fix this drive card, and fire up the power supply, of course with the bad components removed. And I'm going to watch the temperature of the transistors, and I'm going to see the switching of the gates to see if the 3205s are correct for the power supply. The gate resistors are a little, in my opinion, a little low, but they're using pull downs of 220 ohms for those gates. So we'll see how that works out. I don't know the original OEM specifications of this board because there's so many different parts that have been installed. So I will get that back together, and we will fire this power supply up and see how it looks. I'll be right back with you. I gotta come back and make a correction on this before I start tearing this apart. My original excuse me, my original testing of this bank here with the 9640s and the 31N20s, I went from gate to source. So I was reading 25K on the 9640s from gate to source, and I was reading 50K on the 31N20s. But when I take my measurements across drain and source, I have 0.34 ohms. So somewhere in here, 0.33, I have a shorted transistor. 0.33, 0.34, 3 ohms, and 3 ohms. So somewhere along here, drain to source, I have a direct short, which is odd. I don't see this often that I have a direct short drain to source on amplifiers. So I just thought I'd point that out. What I'm going to do is I'm going to remove these and remove these, and I'm going to test these and see if I have a short in the transistor, or do I have a short across the drain source of the board itself. That I am not sure yet. I haven't quite got that far. So we will see where this brings us. I'll be right back with you again. All right, so I'm getting ready to remove the output transistors, and you can see what I do is I label the board. Don't be bashful about labeling the board with a Sharpie. The Sharpie comes right off with your rubbing alcohol, so the worst thing that can really happen is you tear a board apart and you can't remember what parts go where. So that's just a little tip there. Just write your numbers on the board. Sorry for the glare here, and sorry for the noise. I'm going to go ahead and fire up my Hacko, my FR301 here. I know, I haven't been using the 808 lately. It's not growing dust, trust me guys, it's just on my other workbench. So this bench just happens to have the laptop on it, so for recording. So I'm just going to pull these transistors out real quick. It takes just a second to pull these out. It's about time to clean the desoldering gun here. So bear with me. Time to clean it. She's getting a little bit of that. I think this is going to be lead free, so I think these are going to be the original transistors. So sorry about that movement there. So I'm just going to go ahead and mix up some leaded solder here to help clean up these vias. Much better. Yeah, this lead free is, I'm sorry guys, in my opinion, lead free is garbage. I understand its purpose, but it makes for just a headache for repairs. So good old lead free. That's why I think these are probably the original transistors. So I have it marked here as 640, even though the original transistors I think might be the 31N20Ds. They may have changed them around every now and then on the production line. I'm sure the drive can handle both transistors. It's just whichever one was going to run the coolest. Because remember what kills transistors? Heat. I may just heat these up and just drop them out and clean up my desoldering gun. A clean desoldering gun is a happy gun. Let me empty my soldering iron here. Let me clean out my desoldering gun real quick. It was a little full. We need like a commercial solution to desoldering. I'm sure they make much bigger desoldering guns, but that's okay. I'll just keep cleaning this out for now. All right, back at it. Oh yeah, happy desoldering gun. We'll get all these out of here and get things tested. You see, what I do sometimes is I'll just heat up all three legs, pull it out, clean out the vias. If it doesn't get too hot to hold. Oof, that one got a little toasty. It's always nice to have a good desoldering gun. There it is. All right, now that we're done with all that nasty noise, let me clean up my mess here real quick. And remember, underneath your mats that you guys use, watch for the solder balls that fall. I use foam mats. This is foam. So when the solder hits the foam, it just kind of melts into it, and it actually pulls it away from the board. So you have less of a chance of, when you're testing boards, you have a short underneath the board when you're working on it. So we had a drain source short with the transistors in on this bank. So I'm just going to make sure and see that I don't have a drain source short, which I don't. I do show a capacitive charge. Nice. Nice. So there is a shorted transistor in this mess of transistors over here somewhere. So, oh, backwards. So these transistors were on this side, and then these were on this side. So the board short is gone. So the short was in the transistor. And we're just going to double check. Make sure I don't have a board short over here. Nope. Capacitive charge, and looking great. So the board itself isn't shorted. So transistors are shorted. And you guys have a few options when it comes to testing transistors. You can use your meter, you can use testers. I've got a few. So these are my two go-to testers. They do the same thing, but they have different ways of doing it. And I have different values. Like I have my RDS on this one, but I don't have RDS on this one. Probably because this one's a knockoff, I'm not sure, but it does the job at showing you shorts. And I do have a little adapter here that I use in this one here that I had set up for the TO247 size packages here. I got some solder braid here, and I just take the transistor and I hold the transistor against it when I'm testing it to test the TO247 size. So I'm going to go ahead and use this one here, since this one here is really good at just telling me it's shorted. I mean, they both will tell you that they're shorted. And I'm just going to run through 2 and 3 31N20D. Yes. Now, we'll get back to that. This is showing a diode between 2 and 3. That's, I'm going to tell you right now, I know it's kind of weird, but that's good. The 31N20D, that's what you want to see on that. The 9640, PE-MOS, 1.89, capacitance of 1.9 nanofarads, voltage threshold of 3.6 volts. So I'm just going around testing the transistors here. P channel. Oh, self-test. So when it comes up and tells you self-test mode, it'll pretty much tells you you have a shorted transistor there. So this is going to be the 640. Which I kind of suspected. There's your 2 to 3 between legs 2 and 3 diode. So that's going to probably be, I'm going to guess, a 31N20. And correct, it's a 31N20D. Again, we'll go back to why that's important to know that on those 31N20s. And last but not least, self-test. So this is shorted. So the other, so I have a 9640 that's shorted. So I have a 640 that's shorted and a 9640 that's shorted. All right, guys, let's go over these 31N20Ds real quick here. There is some information that I want to provide for you guys. There's my batch of 31N20Ds. I have two batches actually. These are all matched. These all come from the same die, the same time. Except this guy right here. Hold on. SBP. So they're all marked CL25 at the bottom. And let me just give you a quick example. So let me fire up the old tester here. The tester will come up and it'll show you have a diode between 2 and 3, which is good. Drain source. It's showing you your drain source diode there. which is excellent. That's what you want to see. Let me show you the ones that came out of this 31N20D. So this is what came out of the board, just to show you. And there's your 2-3 diode there. So that's good. There's no shorts in that. Now, like I showed you, this is the batch that I have here. I have 2 different matched sets of 31N20Ds. It took me a long time to find an original 31N20D specified transistor. These came from a source that I use for new old stock parts. And they have never failed me. These guys are excellent. And these are original 31N20D transistors. Hard to find. And here I'll explain why they're so hard to find. This is a 31N20D from a different seller. Let's see here. This is a international rectifier FB 31N20D tagged P821D NFZY. So it looks like an new old stock 31N20D. The metal has been, it's old looking. Looks like this has been around for quite a while. Well, let's go ahead and put it in the tester and see what it says. Oh, well, hold on here. What? This is an N-channel MOSFET with a voltage threshold of 1.6 volts? No. Sorry, guys. That will not work in a circuit designed for 31N20s. This will heat up. This will get hot. It does not have the right properties of a 31N20D. So, are they fake? Yeah, probably. Well, they're definitely not 31N20Ds, or at least original specified 31N20Ds. I don't know. Are they fake? Hold on, give me 2 seconds. All right. Have you guys ever done this? Take your side cutters. Sorry, my rusty side cutters. Go at an angle on your transistors. Get a little squeeze. I call it popping the top on these. And what I do is I open them up. A lot of fake or rebranded transistors will have a very, very tiny die. So these are fairly large dies. Would it handle the current? By looking at the die size here, I'd say it could handle the current, but your voltage threshold is way off of an original 31N20D. So that's why I still keep these. They may work in some drives. They will not work in an Orion drive. The Orion gate drive is just too high for these. It may work in this board. It may not work in this board. I won't use them in this board because this is a customer board. So I'm going to put the original 31N20Ds in. If the 640s don't work, again, I don't know what transistor this particular board uses. I have pictures of it using the 640s, but I think with the lead-free solder that I pulled out, that it originally came with the 31N20Ds over here on this side. So I'm out of toss-up on this. I'm going to try both, I think. I have a lot of experience with the 31N20Ds, so depending on the gate drive voltage, I may go with the 31N20D. So thanks for watching. I'll be right back with you guys. All right, hey guys, I just want to show you something real quick here. Let me find something where you guys can see this. Let me pull some transistors here for you. I was just doing a quick die comparison for you guys on the 31N20Ds. I don't know if you can see this. All right, so die size die size is important because die size, well, it's not a primary thing, but really determine current capability. So this is an original 31N20D right here. This is a 31N20D that read as a 31N20D, but I only had the one of that I would never use, you know, in a amplifier because I don't have another pair for that, for parallel sets. And there's another 31N20D that, as you can see, the die size on these are nowhere really even close. So when you get your orders in, if you order from overseas and you question what you have before putting it in any amplifier, pop the top, check out the die size. You'll be surprised. All right, back to this board. I'll be right back with you. All right, welcome back on this board here. So I had to just do some quick desoldering of the burnt gate resistors. I got the new gate resistors in, and I'm just cutting the legs off the bottom of the board here so that I can flip it over and show you guys what I like to do on repairs of amplifiers. I kind of go above and beyond what the manufacturer does originally, just to help maintain the durability of the amplifier itself. So what I did is, let me get my tweezers here. So here's the 4 new gate resistors. You gotta know it's hard to see those, but what you can see is I lifted them up off the board. I do that so if it does burn up in the future, it doesn't burn up the board. Remember what happens with PCB is as it carbonizes. What is carbon? Carbon is conductive. So as you can see, I can fit my tweezers underneath those gate resistors there. Off camera, what I'm going to do is I'm also going to replace these 4 here and raise them up off the board. Again, for just longevity and durability of the board itself. I just am trying to keep the videos as short as possible for you guys. So my goal is to get a drive signal and get the gate signal going on the drive on the power supply. So here's the power supply drive card. I did replace those 2 transistors that got burned up, and as you can see, I also lifted them up off the board. I know Dave, the EEV blog, would be yelling at me right now for having raised transistors, just flapping in the wind there, but typically on car amplifiers you're gonna have more problems than just a transistor falling off from vibration. You'll burn up the output or the power supply first. And they're not so high that they're easy to move. So, and they're separated to help keep from cooking each other. I like to make sure heat gets dissipated as easily as possible on amplifiers. So that's done. I verified the SMD resistors. I don't know if the protection circuit is functional. I won't know until I fire it up. So what I'm going to do is I'm just going to slide this card in to where it belongs here. There's no power supply transistors, so we're not going to build any rail voltage. Again, our goal is just to see the drive of the power supply drive card. Make sure that I have drive on this 494. So again, let me hook up my wires and I'll be right back with you. All right, I am back with you guys. I got the 12 volts hooked up here. My scope is grounded over at the power supply. How do I point here? Right down in the bottom corner. My scope is grounded to the negative of the incoming power. So I get a lot of questions on my scope grounding. How is your signal so clean? Well, it all goes down to how you're grounded. So let me get the voltages set right on my scope here. So I've got it set to, let's go to 5 volts a division. perfect. So showing 12.3 volts on my input power. Do I have any form of lights on my foot pedal? I do. I get a flashing little bit of a quick blinking red light, which is good because that is going to be the protection circuits kicking in. Will it give me a gate drive though? Let's find out. Oh, there it is. So you can see there on the scope, I do have gate drive. A nice, good square wave there. And I heard the relay click in. So there's a transistor that's responsible for the relay engagement on the driver card. This is a really common, besides the pin 910 transistors here. This will vary, but it's a really common design on these. The remote will charge a capacitor. The capacitor will charge or will reach its point, turns the relay on. So again, we do have gate drive. So that's telling me we're good to install some 3205s in the power supply and build some rail voltage. At that point, it probably will turn back off and go into protect because it's not going to see the outputs are installed. Some of these cards will go into protect if you don't have the drive present. So we'll find out. Let me get some 3205s in this thing, and we'll fire it back up and see what it does. Be right back with you. All right, let's get these 3205s in. So again, I have drawers full of transistors. If you're rebuilding or repairing amplifiers, it's always good to have a good stock of parts on hand. Some customers don't mind waiting, but if you have to order parts, it sure becomes a pain. So I try to stock parts as much as possible. I'm going to make sure my power supply is turned off, because remember that your 12 volts is going to be present on the, let me just show you here. 12 volts is going to be present on the drain of the transistors on the power supply. So you want to make sure that your input voltage is off before you start installing transistors. You know, some transistors, you can switch their gates on just by static electricity. And things can go south pretty quick if you have your 12 volts running through this, especially if you're running high current. So I'm just going to make sure my power supply is going to be discharged here. I can always give it a helping hand too. It's discharged, so we're going to go ahead and install the power supply transistors, and I'm going to measure the original length of the transistors to match the new ones. Let me find my marker here, because these do have the spring clip retainers, so these have to be kind of pretty much at the right height. So the top of my marker there is going to be the board itself, the top of the board. So I'm going to just quickly mark my transistors to know my height on those. One, two, three, four, five, 6, 7, 8. I can count. Excellent. Although I had a call earlier today for a E.A.R.S warranty repair, and I completely was off on the math of my months. E.A.R.S repair warranty repairs is 15 months, so I couldn't count earlier this morning, but I can count now. So let me see here. So let's get these 3205s in place, into the board, and these are straight up and down. And again, I use foam underneath my boards, so the legs of the transistors poke right into the foam, and it kind of helps hold things in place. Get them all down. Sorry, I'll be right back. Let me answer this call real quick. All right, I'm back. Sorry, I had to answer a phone call for a Tar-Amps warranty. I've got my soldering iron fired up. It's actually my Hacko here, my 301 that I use as a soldering iron a lot of times. I'll just touch some solder onto the legs here, on the source leg, just to hold them in place. This allows me to flip the board over and have all the transistors still in the right height of where I want them. Like I said, I need these to be kind of the same height, the same level. And then I'm going to go through and I'm just going to straighten it up because these do belong straight up and down. So I'm just going to roll them forward here real quick. That way I can just flip the board over and it takes just a second to solder the other two legs in place. And double check the solder joint of the source leg here. Just like that, all lined up there. Flip the board over. Power is still off, so I don't have to worry about any gates firing up on me. And then I'm just going to solder the legs in. Super easy. Amplifier repair is pretty straightforward for the most part until you start getting into the switching aspects of amplifiers. Amplifiers are realistically switch mode power supplies for the power, and then you have various ways that the manufacturer switches the output, whether it be class A, B, class D, some of the Rockford BD amps. Manufacturers just have several different ways of switching transistors. And that's when you are going to get into, needing a scope. Best case is needing a scope, otherwise you're going to be chasing your tail if you can't resolve a problem. But the scope will really tell you what's going on. So I got all the transistors soldered in place. I'm just going to make sure that none of the legs are loose. Perfect. We'll flip it over. Keep this in view for you guys. All right, power supply's done. Make sure I'm not sitting on anything conductive. Now this is where the amplifier's probably not going to be so happy. My primary goal is to check for rail voltage. And the easiest way to do it is at your rectifiers. If you just bump your remote, I use a foot pedal on my remote. If you just bump the remote, you will see these rectifiers. So there's your negative rail and your positive rail. You'll see the rectifiers will build voltage really quick. So what I'm looking for is the rails to build and not drop like a rock or go up like a rocket. You want them to just kind of sit still. If there was any form of short in the board, your rails will discharge quickly. So 20 volts, 54 volts. So let's see here. Will this thing start without any output? Let's find out. It will. I have a green light, relay clicked on. Let me check my rail voltage here. So we are at 56, 57 volts on our rails, which is looking great. So we have rail voltage. Do we have, we should have a signal coming from this card here. For you guys that are familiar with this card, again, you will find these in the Orion, and I think some of the Soundstream amps use these. This is a crystal here for an oscillating signal coming out of this IC right down here. So somewhere around here we should have a signal. Ah, there it is. So this signal here is what drives your cards. So there's one, there's another one floating around here somewhere, unless they're using, oh, there it is. So you're gonna have a low side, right? Yes, yes. So we do have drive coming out of this card. So this card is fine. This card survived any of the faults that happened on this board. So from here, what we can do is try and see if the card, again, remember you have rail voltage here, which means you're going to have rail voltage at your output transistors, and you possibly will have rail voltage on your, yep, right here, negative 60 volts on where your card goes. So you want to be real careful when you're putting cards in, taking cards out, or dealing with transistors. You always want to make sure your rails are discharged. So we're at 30 volts. So let me grab my quick discharge here. It's really easy. I just use a really big wire wound ceramic resistor down below. The thing is huge. Let's see, do we get an arc spark? Arc spark? And that is just like that. Your rails are back down to 0. So now we can try a card. I suspected this side was fine, which this card here came from this side. So let's go ahead and see if this thing will oscillate with no transistors in. It's either going to yell at me or it's not going to yell at me. Oh, and there it is. So we do have drive. Yep. Nice. This card is functional. That's exactly what we're looking for, which is good because this will give you a basis to go by if this card is not functional. So now what I'm going to do is I'm just going to take this card out, and I'm going to put the card in that had the shorted transistors. Again, I'm going to discharge the rails. Watch your eyeballs. Not a lot of current in this rail here, so rails are back to 0. So let's go ahead and remove this card. And let's go ahead and install this card and see if we have a proper drive in this card. We'll cross our fingers. Let the rails build. Relay clicks. Oh, well, look at this. We have a low side drive and we have a high side drive. So both cards survived. That is excellent news. And all our gate resistors are okay. Yep. Which is fantastic. So this really just means what we can do from here is you can install one bank at a time. I mean, you can go all out and install everything at one time if you'd like, but again, this amplifier will run with one bank done. So knowing that the cards are functional takes a huge load off the repair time itself. And it allows time to just see if we're going to use the 640s or the 31N20Ds. So Again, I'll be right back with you. Let me get some transistors lined up. Stay tuned. All right, I am back, and let's see here. Let's get this back into shot. Sorry, sometimes I get things all scooted around here. So I have one card installed, and I have the banks installed. The transistors have pull-down resistors, so I don't foresee problems not having a drive card in. If this board didn't have pull-down resistors for the gates, I wouldn't have installed the transistors. You don't want those turning on inadvertently due to statics or anything. So they have pull-down resistors, so that means the gate will stay off. Well, hopefully. That's the goal. I do have my thermal camera here. And what I'm going to do is I'm just going to bump the power supply just till it starts to oscillate. Because what I'm going to do is I'm going to watch the temperature of the transistors. So remember what I said earlier, those 31N20Ds, if they work, they will not heat up. If they don't work, they will heat up really quick. I'm just checking my rail voltage here, making sure it's building okay. We're looking good. So I'm going to go ahead and let it oscillate. And I'm checking the temperature of the transistors. So these transistors are looking great. The 31N20Ds are the coldest thing that I'm seeing right now, besides the transistors here that drive the output. So I'm going to go ahead and check for switching. So there's our low side switching and our high side switching. Do we have any form of drain switching? And there's the drain. So I mean, so the output of these are switching just as I would anticipate, just as expected. So this bank here is running great. So now what I'm going to do is I'm going to discharge the rails again. Remember, just keeping your rails discharged just is insurance that you don't inadvertently fry your own work. So I like to make sure I don't have any rail voltages when I'm removing or installing cards. That holds true for amplifier installation. Don't hook up your speakers while the amp is running. Don't unplug and plug in your RCAs while the amp is running. Just avoid that, especially with some of today's high current amplifiers. It just takes a simple short on the output to destroy an output section of an amplifier. So just try to avoid that. So I have installed the new card on this side, and we're going to go ahead and fire up the amplifier. This side was good. This side is what we're checking now. So I've got my thermal camera ready to go, and let's fire this board up. And the 31N20Ds are as cold as can be. So let's go ahead and check for switching signal here. And we do have proper switching of the 31N20Ds and the 9640s. And the voltage regulators over here, these naturally, they do run hot to begin with. So right now I'm just doing a general overview of the board itself to see what is heating up. Looks like just everything that should be heating up is heating up normally as expected. Looks great. Looks great. yeah, so make sure I don't have any abnormal noise on the output. Nope, no abnormal noise. So let's go ahead and put a signal into this amplifier and see if we can get some proper oscillation of that of this card here. Let me get my RCAs here for you guys. Excuse my reach across the cameras if you notice my arm poking around there. What's input? What's output? Hold on, let me check the end plate. Let me check the end plate here. So the input is the one that's furthest out. So the input is the RCAs closest to the outside edge of the board. Let's go ahead and turn the signal generator on. I'm starting off with a 1.5 volt for the input voltage at 50 hertz. So this is where you're going to start to see transistors get a little warm. As soon as we start to get the oscillations going on the preamp there. Good, good, good. All right. Let's see. Do we have any sort of signal? Let's go ahead and change the time base of the scope here to see what we got going on. And there it is. There's the output. So we've gone from burnt up power supply to shorted output section to a working amplifier. And that's how this is done. This is how I do it. This is probably 90% of all the repairs I do. This is kind of the process I go through. And we just we get them taken care of as quick as we can and keep things efficient. So I do thank you guys for watching. Please like and subscribe down below. And I try to release content of various types of amplifiers as much as possible to help keep things diverse. And I try to keep things simple to where people can understand what I'm talking about. So when I say the word transistor, a transistor is a three-leg device that controls voltage or current. So, I mean, if you want to look up the definition of a transistor, you have hex FETs, MOSFETs, you have you have a whole bunch of different kinds of transistors. But I try to keep things simple. So, thank you guys for watching. I'll catch you on the next one. Stay safe. Keep your fingers out of the rail voltage, too. Remember, it's dangerous. Catch you on the next one.